Okay guys, let me just take you through the little intro for this first section of the stuff on matrices. It just gives a general overview of what matrices are, the general notation, and the simple operations on matrices. So here, for example, is how you would write a matrix in general form. So the 1, 1 here, row 1, column 1. You see a matrix in general consists of a rectangular array of elements. I've written it there. Here we've got an m by n matrix, so you can see it. There's m rows, so that's an m, and then n columns, so we describe it as m being the row, that comes first, then the n, the column, comes second. So it's an m by n matrix. M by n matrix, yeah? M rows, n columns. The notation, we use a lowercase a for the elements. These are called the elements in a matrix. Here, elements, so I'll put that word in. And the first row, first column, there's A11, first row, first column. Second row, first column, A21. Right down to the nth row, first column. Then you move along to the second column, and you've got first row, second column, second row, second column, and then you would go down to the nth row, second column, wouldn't you? And then you go along to the end, and you'll get the first row again, the nth column, that's A1n, second row, nth column, and then finally, at the bottom right, you'll see the mth row, nth column. This is the arrangement we have then for matrices. It's this way round. M by n is m rows, n columns. So some examples here. 2 by 3. So that's a 2 by 3 matrix there. So those two. Oops. Different color helps, doesn't it? Those two are linked. That's a 2 by 3. This is a 3 rows, 2 columns, so that's a 3 by 2. Yeah, this is 3 rows, 1 column, so that would be a 3 by 1. And you get the idea, and that was a 2 by 3, wasn't it? So the rows come first, then the columns. It's rows, n columns. So 2 by 3, 3 by 2, 3 by 1, and that's the arrangement. Square matrices means they're, well, it's a visual picture there, they're a square. So the same row number as column. Yeah, so this is a 2 by 2 square matrix. That's about it. This is, what would this one be then? This would be a 1 by 4, wouldn't it? 1 row, 4 column entries, yeah? Often that's termed as a row vector, and this is termed as a column vector, but we're just going to use matrix notation here and terminology. So this would be a 1 by 4 and a 3 by 1 there. Okay, then that's a general arrangement for matrices then. Now we want to know how to add and subtract them and multiply them by a scalar. Very self-evident and best explained by examples. So basically all you do to add and subtract is you add or subtract the corresponding elements. So here, for example, I've written an example, -2 plus first row, first column. So it'll be -2 there and 4 there. So -2 plus the 4 would give 2. And then 4 plus 1 would give 5. And then a first row, second column, 3 plus and a minus is a minus, so 3 take 3 is 0. And then 6 plus 7 will give you the second row, second column entry, 13. Similarly for minus, just keep account of the sign, so -2 minus 4 will be -6. And then 3 take away -3, well that'll be +3, 3 plus 3 is 6. Those two, and then 4 take away 1 is 3, and then 6 take away 7 will give you -1. So you just run through, either if it's a plus or a minus, you run through it like that, yeah, and add the corresponding elements. It's basically self-evident on what you would think would have to happen. Okay then, so scalar multiplication then is next. All you do here, again, it's just common sense. 2 lots of this 1 by 3 matrix, you scale up each entry by a factor of 2. So 2 3s, 6, 2 4s, 8, and 2 7s, 14. And then you've got -3 lots of this matrix, this 2 by 2 matrix. You're going to get 12, -15, -9, and +6, yeah? And there they are there. Okay then, so that's pretty self-evident and just common sense. So let's have a look at matrix multiplication then, just briefly, which again is in this section, at the end of the section of questions. Best explained by examples. The first thing to note is that they need to fit together. rows with columns. So for example, this matrix here is a 2 by 2. This is a 2 by 3. So we're wondering what the first row, first column entry is, yeah? So here's the first row, and here's the first column. And what you do is you peel the first row off the page and put it alongside the first column, yeah? So I'll try and write that a bit clearer actually. So first row, first column entry. You peel this off the page in your mind's eye and you put it alongside this entry here. So you get 4 2's and 2 times minus 3. That's 8 minus 6 is 2. So that would be first row, first column. First row, second column. Again, you peel this 2 and 3 off in your mind's eye and put it alongside the second column. Minus 10 minus 18. Minus 10 minus 18 is minus 28, isn't it? And then first row, third column. So that would be the 2 and the minus 3. Peel off in your mind's eye, put them alongside the third column. First row, third column, 6 minus 12 is minus 6. Then you repeat the same process, but this time we do it, so that was the entries for the first one then. Let's just do it again for the second row, first column now. So we did that one, and that one, didn't we, just now? Now let's do the second one. This time we peel off the minus 4, 7, and we swing it around and put it alongside the first column. Second row, first column, so we're talking about this entry, and it would be minus 16 plus 14. See it, minus 16 plus 14 is minus 2. And then the second row, second column, again we just peel that off in our mind's eye, and we've got 20 plus 42. 20 plus 42 is 62. And then lastly, the second row, third column, in your mind's eye, the minus 4, 7, the second row, comes alongside the third column for the second row, third column entry, which is here. Minus 12 plus 28. 28 take 12 is 16. There we go. So that's that one done. So can you see we just done all 6 entries there? So you can see exactly what you get then, can't you? You're going to end up with a 2 by 3 matrix. Whoops. So you end up with a 2 by 3 matrix. So we did row, column, first row, first column, first row, second column, first row, third, and then second row, so that was these 3. They're not zeros, they're circles. And then second row first would be here, second row second, and second row third. So that's what we mean when we say they fit together. This needs to peel down and fit alongside here. If it's a different number of elements here that doesn't correspond with the number of elements in the column here, then we can't multiply them together. The product would be meaningless. Okay? So they have to fit in the arrangement we said. So we end up here with 2 rows and 3 columns. Here's the number of rows we get in the product, and here's the number of columns. A 2 by 3 product here. Okay then, so I pulled some teeth there, I think, by explaining that, eh? So AB is okay here, but if we tried to put it in reverse, B times A, you can see it wouldn't fit, because you'd have 3 and you'd have to put it alongside the column here, where there's only 2. So BA wouldn't make any sense there. So in general then, it's true to say that this doesn't hold always. It's the case that this doesn't always hold. The AB is not necessarily equal to BA. Okay, so that's not a rule we can use as with normal numbers. A couple of little things then. Identity matrix, I just want to say a brief word about that. If you times a matrix by this, if it's a 2 by 2 square matrix, or a 3 by 3, if you have a 3 by 3 matrix and multiply it by this, you'll end up with the same matrix. So I'm just going to illustrate that here. So that's the first row, first column. Peel the 3 2 off in your mind's eye and put it alongside here. The 2 noughts will be noughts, but you'll get a 3 times 1 is 3 for the first row, first column. First row, second column, you can see 3 noughts are naught, 2 1s are 2. So that was the first row, second column. Yeah, and that was a 2. And then second row, first column, yeah. The 4 times 1 is 4, minus 6 times naught is naught, so that would be 4. And then the second row, second column, 4 zeros are 0, minus 6 times 1 is minus 6. Can you see that's the same as this? And if you do the same in reverse, so this first row, first column, you'll just end up with the 1 3s, which are 3. First row, second column, 1 2s, which is 2. And then second row first, you'll just get the 4, won't you? 4 times 1. And the second row second, you'll just get the 1 times minus 6. Same. So that's why we call it the identity matrix. It's akin to multiplying a scalar number by 1, so to speak, isn't it? That's what we think of it as in. It's akin to timesing by 1 in the real number line. The null matrix is akin to 0. You know, when we think of the 0 number, well, we can put the null matrix, and that's the matrix with zeros in all the elements, yeah? Okay then, that's all I want to say in this intro then. All the best with the questions in this section. Everything you need to know we've covered now, and there's 20 questions or so, I think, in this section. Okay, catch you in the next one. Cheers!